So guys, in my previous video I've shown you how to make a booster that is actually pretty powerful, and if you still haven't watched my previous video of this playlist, then do check that in the cards above because that was insane. In this video I'm going to show you how you can add a feedback to it. So let's get started. So first of all, what is the necessity of a feedback, right? It was working just fine as we've seen in my previous video of this playlist. Then why should we need a feedback? So the thing is that when we are actually setting the output voltage using our potential divider, we are actually kind of able to set the output voltage, right? But you have to understand, how does the output voltage is getting changed? We're basically not monitoring the output voltage but the PWM duty cycle, right? And when we are actually providing less resistance using our potentiometer, the Arduino pin is getting more voltage, and it is in that way detecting that we are actually providing more voltage, and according to that our PWM duty cycle also increases, and as the PWM duty cycle increases, the output voltage also increases, right? But here comes the problem. For a small load, let me say we are giving 50% duty cycle to our 32 kilohertz PWM signal, and it's resulting in around 27 volts for my small DC motor. But this 27 volts will vary for another load, and you may have seen that in my previous video, right? When the voltage is slowly increasing to 30 volts. There we go. Wow, you can see 27 volts. Still going higher. 28, 28.3. Well, this thing is working like a charm. 30 to 1 kilohertz is amazing. It's still increasing 29 volts. As I've not adjusted the duty cycle, I've kept it fixed, but still the voltage is increasing. That's maybe because of the resistance falling. I don't know why it's falling though. Maybe for some reason the resistance is falling and the voltage is slowly increasing. And that's where we need the feedback. In feedback we actually monitor the output voltage, and according to that output voltage, the PWM duty cycle also gets monitored. It's like we are setting the output voltage using our potentiometer, and also the output voltage is feedback to one of the pins of the Arduino, and then the two voltages gets compared, and if the input voltage is increased, then the PWM duty cycle is adjusted in that way so that it also reaches that output voltage, and that is monitored. The output voltage will not increase neither decrease according to our input voltage, that is we are providing through our potentiometer. Isn't that simple? Now you may ask, how can we feed back 50 volts to our Arduino? That will fry like a fish finger. Well, not fish finger. That will fry like a barbecue. Well, does barbecue fries?
Does barbecue gets fried?
So to reduce the voltage to some suitable values, that is Arduino's 5 volts, we need to give it a potential divider. Now what is a potential divider? I will discuss about this in my basics video, but the basic concept is by using 2 or more resistors, you create a network that actually step your voltage from 50 volts to 5 volts. And there is a suitable website I found on internet. So see, you can calculate the potential divider using this. So you have to just put the V in, which in my case 50 volts, which is limited as I don't need that amount of voltage, and I need 5 volts up in here. Okay, so and now if we press calculate R1 and R2, you see I need around 9 kilo ohms and 1 kilo ohms, and you can see the diagram happening here. This is V in and this is what our voltage is, that is 50 volts, and which is just passing through R1, that is our 9 kilo ohms. And then this is the V out, and we are getting our Arduino analog pin attached to it, and then again another pull down resistor to ground, that is gonna be our 1 kilo ohm. So up in here you can see typical maximum and minimum values. This is pretty useful according to my opinion. So I've just put a, you can see here, a potentiometer which I've adjusted to 90 kilo ohms, and this is a 10 kilo ohm resistor which is pulled down to ground. And now I have to change the code a little bit. So guys, for the code I'm not going into detail because I have already beginner Arduino series and advanced Arduino series. So if you wish to, you can check that out in my channel itself. So just I have used the normal concept of just checking the potentiometer input and the feedback voltage input, and then comparing that both, and if the potential voltage is greater than the feedback voltage, then the feedback should increase, the voltage should increase, and the opposite, like if the feedback voltage is greater than the potentiometer voltage, then the feedback should decrease, and that's how it works. So, and the plus point of this thing is, as you've seen, when I kept it on without load in my previous video, it reached 150 volts. So see what I've got. I've not recorded the steps, but I got 100 volts from 10 volts by using this. As you can see right there, 115 volts. So you got your proof, right? See, it's still increasing. Oh, 142. Holy sh**. But that will not happen in case of feedback, because the feedback is constantly monitoring the output voltage to be exactly as the set input voltage. And you can see that using this graph. I have set the input voltage to be 16 volts using my potentiometer, and as you can see, it is maintaining that 16 volts. And by looking at the serial plotter, that is displaying my PWM duty cycle, you can see it not always constantly turned on. It sometimes turned off and again turns on to maintain that 16 volts. That's kind of amazing, right? For the first run it works just pretty fine, but the problem is the voltage spike. And as soon as I remove the load, a huge voltage spike is going in the Arduino pin, and that is reaching around, I can read in the output voltage in the multimeter is around 68 to 70 volts, but that is stepped down to 6.8 to 7 volts. That is not recommended to put in your Arduino's analog pin. So after 4 hours of troubleshooting, I figured out that maybe that capacitor problem, because the capacitor is taking a huge time to discharge, and that's throwing much more higher voltage in there. So I replaced the capacitor with the lesser one, and now the thing is quite same, but the spike is a little bit sharp. It's reaching 70 volts and then immediately dropping, but that's also, it's around 6 volts spike. I don't think the Arduino like it for a longer time, and this is the only thing I cannot figure out how to solve. I have figured out and provided 100 microfarad capacitor in place of 1000 microfarad, and it solves the problem a little bit. The spike is sharp now, but still it's actually going higher than the desired pin of my Arduino. When I set the output voltage to be exactly 50 volts, that is the limit of my boost converter, and I remove the load suddenly, then it is taking quite a bit of time to actually reduce the voltage, and that is enough for the capacitor to take up more charge than 50 volts, and then discharging the whole thing into the analog pin of my Arduino through the feedback, which is reaching around 68 to 70 volts, but that is actually stepped down to 6.8 to 7 volts. So if anyone have any suggestion how to fix this one, then feel free to leave it in the comment section below. because that is what may be a little bit of problem while using this converter. That will not be a problem if you don't remove the load while the converter is running, which will not happen, I guess. But you know what, I like perfect. So that's all for today. Hope you have enjoyed and understood whatever I told you. If you have any doubt, then you can freely leave that in the comment section below, and give it a thumbs up if you liked it, thumbs down for the opposite, and share with your friends as much as you can, and do subscribe and hit that notification bell icon to get notified about my latest uploads. That's all for today. This is Malhar. You are watching our Syllabus, and I am signing off.